So as we alluded to earlier, this is a two-phased investigation. Jim's group from SPAWAR will be working with the Trident probe that he talked about to do their survey, which will help us figure out where fresh groundwater from Yerba Buena Island might be discharging into Clipper Cove. And in addition, that same tool, the Trident probe, which was actually developed by the Navy's technical group in coordination with Cornell University, is going to be used to collect the pore water samples, and that pore water is what Mukesh just described. It's the water in between the sediment particles. So that's phase one, is using the Trident probe, taking a look at what that tells us, and then we have a second phase of field sampling, which will be to collect sediment samples. And Jim Leather is here to tell us about the Trident probe portion of the survey. He's our technical expert and will be explaining that part of the study in the next couple of slides. And then I'll tell you more about the sediment investigation.
Thanks, Katie. So for the first phase of the investigation, we're going to be using what we've termed the Trident probe. And on the left-hand side is a prototype version of the probe that we developed back in around 2005. And the main idea here is that we're basically using metal rods just to push down into the beach sediment to look for two things. The first phase, we're going to be looking at temperature and electrical connectivity. As many of you probably know, bay water is salty, so that it will conduct electricity, whereas rainwater, which becomes the groundwater, which is then flowing out along the beach into the bay, is fresh water, which doesn't conduct electricity. So we can use this connectivity probe to tell us the difference between bay water and fresh groundwater. It tells us essentially where the groundwater is emptying out from Yerba Buena Island through the beach into the bay. So we want to get some idea about where there might be a potential source of petroleum being carried out by this groundwater. The connectivity probe gives us an idea where to look, and then in the phase two section, actually collect that pore water for chemical analysis to look for that petroleum. The second probe here is actually a rod setup that has a screen on the bottom that we then push in, which can collect a sample of that water for the chemical analysis. On the right-hand side is just a modern version. We've had several versions of the Trident probe. We've revised this now so that we have a GPS for positioning on top, communication back to the beach through these wires to computers so we can collect the data. And also, in addition to just having two locations for probes, we now have the ability to include up to 6 locations for those probes. The benefit of that just is that we can, in parallel, collect multiple groundwater probes at the same time. So I sort of use this when my kids always say, well, Dad, what do you do at work? And I try to say, well, I go to the beach just like you guys, and I play in the mud, okay? But what we're really looking at with this Trident probe is, how to collect chemical samples from the water in between those grains of sediment, as Mukesh was trying to give you an example of. So my analogy for that is just sort of like this Trident probe is sort of like when you go to just any fast food restaurant and you order a milkshake, okay? Very fine-grained material like the slurry that's in the milkshake. If you put that straw in there, which a straw is basically one of these probes, it's very difficult to suck out a sample. In this particular case, where we're working in the intertidal areas of the beach here, we're going to see it's more like when you order a Coke or something at the restaurant, and the grains are like the ice cubes, and the water in between is like the Coke. It's very easy to put that sampling device, a straw, in and recover a sample. So the whole idea of the Trident is we've developed this tool so we get easy access, rapidly recovering a sample of that water, that pore water in between the grains. So it's like drinking a Coke as opposed to trying to drink or suck out a milkshake. Go to the next slide. The second phase, the second step in this phase 1 is this recovery of the water from those zones that we've determined to be this fresh groundwater. And this is a picture in an intertidal area where we're using the Trident, and we've removed all of the electrical lines, and we just have the sampling line to the Trident to recover the pore water samples. So we hook that up to a pump, and we slowly suck out a sample from each location. And as Mikesh showed you before, in the map of the site, we're going to essentially put a grid of samples centered around that storage tank location and work our way out so there were some elevated petroleum concentrations near that tank, but there weren't quite enough sample locations to allow the regulators in the Navy to come to agreement about how big of a contaminated zone is that, how much of a problem is that. This will give us more locations to bound where that potential petroleum contamination is present. And so we collect those samples, and then we then send them into the lab to be evaluated for a number of contaminant analyses. And in addition to just looking at the amount of petroleum that's present there, we're going to also be looking at the types of petroleum products that are present to try to determine a fingerprint of that material. It helps give some idea about the weathering patterns and what the source of that petroleum might be. So with that, I'm going to hand this back over to Katie to go back through the second phase of the investigation.